Soy Ricardo, matemática Jesús Vega Valdez, 01665330 para la materia de análisis de circuitos eléctricos. So today we're going to be working with two circuits. Right away we have the first one, we're going to be using the mesh super mesh method to solve it. Also we have the second one. The second one is going to be, I'm going to be working with nodes and super nodes method to solve it. Why am I going to use that method? Because our evidence asks us to do that. So, also we have previously solved that circuits, that problems on our written solution. Later I'm going to be showing that. Right away we have to simulate them. I'm going to be using multi-sim because it's a little familiar to me. We have a totally brand new workspace. If there's nothing there, we're going to be doing the circuits right away. So, I'm going to split my screen. There we go. So it should be easier to look at that. Okay, we have 6 resistance. So that means we have to copy paste 6 resistance. We have 6 components of that kind in our circuit. We're going to be using that. Also, we have to change the values of that stuff. Why? Because we need to make sure they don't have strange values, or in the case, imagine 15k ohms on our circuit is going to be a lot for our voltage sources, so that shouldn't work. Wait, you know. 21, 20. This one is 53. And this one also is 17. So now that we have a resistors, we are going to be flipping them and taking them to the spaces we are going to be working with. It should be good. So that should be something like this. Also, our free node right here. There you go. I'm going to make a little bigger spaces right there. Okay. This one should be also like here. Like here, there, R4, 20, there, R6, 17, goes somewhere like, I don't know, here, this here, also that here. So, now that we have our resistance, we have to include our power sources. We have 2 dependent ones and 3 dependent ones. We have a voltage, direct current voltage source, that's the 5 volts one there. We have a direct current source, we have a 2 amps right there. Those are independent, they doesn't represent the problem or threat to our circuit, or to us. The problems are going to be these 2. We have 2 dependent sources. So what does it mean they are dependent? That they depend, as its name says, they depend on a voltage or a current to work with. So in this case, we have a controlled current source. Why that? Because we have because we have a current there, a current here. This one's a little different. We have a controlled voltage source. Why? Because voltage sides and voltage arrow and current. Right away, we have to add that. So knowing that, we're going to add our first we're going to add our independent ones. So I'm going to change that symbol to be similar to the circuit we're working with, and so I'm a little more comfortable with that. Also, a direct current it goes right there, something like that. Yeah, something like that. There it goes. So that's not a problem. We are working with 2 amps. I have to be careful with that. There you go. The dependent ones, as I've already said, we have to look for the current control current source. So current. There you go. Oh shit. Current. I don't know how to spell, I think. Current control current source. They appear right away because I've been working with them just a little way too much these days, more than I'd like to admit. So, okay, that's important. I've portrayed that before with respect to the direction already given by the circuit, and also the directions that we suppose are there in our solution. Later I'm going to be showing that directions on our written solution. But right away, I'm just going to flip it on that direction. Also, I'm going to do the same thing with the other one. That one was a voltage controlled voltage source. So, crap. Okay. Voltage controlled voltage source. It's this one. There you go. It goes here. Also, I'm going to flip it just in the direction our circuit says. Also, we have to change the values. This one is working with 10Vx. That means we have to change the value. It will be lovely if you help me there. There you go. Also, this one works with 5Y. So, there you go. So now, this part, we're going to be wiring all our stuff. So, also, one of the reasons I don't like working with Simulink, we have to ground out all our circuits. Why? Because if we don't do that, it doesn't work. So, first of all, we're going to begin wiring all our stuff. So, RC also goes like here, this goes here, this goes here. Here, R5, R3, there, this goes, okay, I don't like how this does this. Here, there you go, keeps, there you go. There you go. Also, R3 should be connected directly to here. There we go. These R5 to the. Okay, so now I've already connected our terminals of our voltage source. But this is important. Besides our dependent sources, we have a bar. It's a control bar or a terminal bar. That says that's the one that indicates the current or the voltage we are working with. So as we know, we are working right here with 10Vx. That means we have to work with the voltage that comes from Vx. That means the voltage that goes through the 15 ohms resistance. Also, R1 should be close right here. It goes here. Let's see. There you go. And this one goes to R3. That's just the same speed there. The control. I've already connected the control bar, right? Oh, here it's a mistake. No, that doesn't go here. This one goes here. So this one doesn't belong here. This one goes to R4 to our central node. The current comes from there, and the current comes from R4 and goes to R3. So there. I think our circuit is completely connected, and now we're going to be getting our right. This is our gradient solution. I'm gonna show you right away the solution. As you can see, we have I4 already given. That's the way we calculated IY, I1, Vx, I2, I3, and also I1. That's it. It's just I1. All right. So see to the solution. Maybe it's there and right here. It's like a cloud B, right? Now we can go to the values we've already obtained with this gradient solution. So now we have to be able to find this stuff. So that goes there, and also a lot of currents. So first of all, this current, also current right here. Current that comes here. I think here. This is wrong. This should, yeah, that's voltage. Vx, right? That's voltage. Current goes there. Voltage. Here. There. So we run it. We've already found. Check this. We've already found. This voltage comes right here. So there you go. We have 10Vx, we have I4, we have I3. This doesn't show the value, and I like that. There you go. Flipping it. There you go. We have I2, we have I2, I3, I4, 10Vx. We need also Vx. Here. So that should be there. And also a current here. Okay, so now we have, I'm gonna stand up. So we have Vx, we have I3, using Vx. We have 192, but it's 90.28. It's because that says that's multiplied by 5 because of the gain, right? On our circuit, it's multisim works like that. Simply works like that, so I can do much about it. So we have I4, 2 amps. We have I1, 3.57184 amps. Goes right here. We have I2, 1.28. We have it right there. I3, 1.66. I4, 2 amps. Vx. Okay, you're gonna be asking, this is a 24. That's weird. But this is just making the suma from 5 volts and the I that comes here. So that leaves us with 24. If you make this the suma, we have 19.28 with 5 volts. That gives us 24. And 10Vx, 192. We know that's correct because of the Ix. So it's there. So we have our first circuit. Yay! So, keeping with our circuits, this is the second circuit of the evidence. This one is going to be solved by the nodes and supernodes method. So just to you to be a little easier to identify my nodes, this is going to be A, this is going to be B, this is going to be D, E, and C. Also, careful. We're going to be working with that one as our reference. And, yeah, don't worry. There you go. As I've already said, we have to mark our nodes. A reference that goes to ground. So we have to be careful with this current, and you're going to ask why. Because we're going to be working with an independent current source. That means we need the current to work with. So as you can see, we have 5 resistances. That's easy peasy. Also, we have 3 different independent sources. We have 2 voltage ones, direct current voltage source. one with 16 volts, another one with 8 volts. Also, we have a direct current source. That's 1 milliampere. Also, the reason for problems, the dependent one. This one depends on the current of Ix. That means, as I've already explained to you, this is a current controlled voltage source. So, now we simulate. As you know, we create that circuit just in a brand new workspace, a brand new file. The charge. Come on. All right. So, first of all, 5 resistances. There you go. Now we begin changing the values. 2K. There you go. 2K. There you go. 3K. There you go. 6K. There you go. 8K. There you go. Also, the direct current, we're going to be changing the symbol for me to be a little more comfortable for working with them. That's 16 volt. We're going to change right away the direction just to be respectful with the direction already given for us to with the circuit. There you go. 8 volts, 16 volts, 8 volts. There you go, 8 volts. Also the same direction. The direct current one. That's in that direction. It's 0.1 milliamperes. And the dependent source, as I've already told you, that's a current controlled voltage source. And we have it right here. There you go. It is indicated on the same direction of our circuit. It's for K. Why? Because all our resistors are in K. So our one's going to be here. We flip it. It goes something like here. You go here. There you go. 8 volts. This one is the 8 one. You go here. Careful. You go something like here. Maybe. There. You go. There you go. There. You go there. You go something. You go there. R2. You go there. I have a rush a little because it's a little late here at the campus. So that means security is going to be near telling me to go. Rush. Also, I think it's already everything here. So I'm going to wire it all. I need my node here. So this. There you go. The ground. There you go. It goes right there. 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 And as I've already said, the connections, we have to be careful with them for the dependent source. So this one is going to go here. No, it doesn't belong here. We have to close the circuit. That goes here. This one goes here. This one goes also here. And this one goes, I think, something like here. So it should be working right now. There you go. Great. So now we can go to the solution that you got there. I'm going to leave it a little seconds right there. That's the solution. I'm going to make erasing these to make it easier to read. Right? There you go. As here it says, we got VD, VD, VC, VD, VA, IX. We have all the nodes, alright? And why is that important? Because we're going to be having them just here. So, taking the current is IX. IX should be taken somewhere here, right there. Voltage. This should be 2 amps, I think. There you go. Voltage there. Voltage here. Voltage here. And voltage here. So now we run it, and we got everything. So we got VD 24. We got, I think I'm missing. We got VD 12. Oh yeah, I'm missing VA. VA. There you go. This one should go. Okay. That's zero because of our reference that goes to the ground. So don't worry. And we have menos 144 nanovolts. So that's nearly 0 volts. Just to be careful. So we got the 8, that's 0. We got it right here. We got 8. This is VV. If you remember our notes, we have minus 8. That's VC. Sorry. We need VV. That should be something somewhere here. You got 8. You got VD 24. IX it's 2 amps. The voltage right here is 0. That's VA. VA. This one is VC, and this one VA, and this one right here is VD. There's our solution.